Here is my presentation that I used with the engineering design process to build my periscope. The engineering design process consists of several steps, including to ask or to define a question, to research and imagine, plan and design, create and build, and then finally test and improve. Asking a question. The engineering design process starts with a problem that is defined, and you begin to ask questions about it. The problem I identified is I want to see over our 6-foot privacy fence, but I'm too short. So my question is, how can I see over the fence without standing on top of anything? Research and imagine. I utilized research by looking for existing solutions to the problem, how I can make it better, and how I can use these solutions to answer my question. The solution I came up with is to build a periscope that can be used to see objects that are at a direct sight. The next step is to plan and design. While I started my planning, I asked a lot of questions. What shape should my periscope be? Would it work better if it was rectangular or cylindrical? How long does the periscope need to be to see over the fence? Will the length impact the use? Can it be too long? Can it be too short? And then what material I needed to create. This is my plan for my periscope. Materials needed. I needed cardboard, 2 small mirrors, marker, ruler, tape, a utility knife to cut the cardboard, and some type of scoring tool. For designing my structure, I thought about how long my periscope needed to be. I needed it to be long enough to see over the obstruction, my fence, but not too long that it was out of control or that the mirrors maybe didn't work the way I wanted to. The shape. I decided to make my periscope rectangular. Mirror placement. The angles of the mirrors will need to be placed at exactly 45 degrees to reflect properly. The end caps. I decided to make end caps for my viewer end where the periscope end over the fence will be, creating a sealed environment to prevent leakage, and I had to figure out how the best way to attach all my cardboard pieces would be. Here's my method. I'm going to walk through the next steps with some pictures. I started with cardboard. I had to cut 3 different pieces. I have a 10 by 18 and 2 11 by 6. On the first and the third panels, I cut 2.5-inch squares out, and I did the matching 2.5-inch squares out of panel 3 on my smart pieces. I used a scoring tool to help fold my cardboard. I taped with packaging tape my 3 individual pieces. And then I attached my mirrors at 45 degrees in each of the sides of the periscope. The next step was to build my periscope, attaching the 3 individual pieces together. Again, I used tape to do this. I did have to make sure that the pieces were completely touching and sealed completely so the light was not coming through. The last picture is looking through the bottom eyepiece. You can see I am looking at, it's a cow with some sunflowers on its head, which is on my wall that I was down on the ground and looking up at the periscope, and that's what I could see. Test and improving. Usually your first time trying something isn't going to work perfectly. You have to make improvements to your prototype. My one thing that I found out is about my mirrors. I did not have them in exactly 45 degrees. My bottom one I had to remove and replace at the correct angle. 2 improvements I did make. I extended my periscope. At first I started at 12 inches and then I made it to 16 inches to increase the height that I could see over. And again, I had to tape all my connections tightly to limit the light leakage so I could see properly. And here are my references I used to build my periscope. And finally, here's my final periscope.